everyone. So I'm Or, I'm part of the DevX group. I lead the Bazel build team, the team that builds, that is in charge of the build system, and we build with Bazel, which I will talk about in this talk. So let's just begin. Usually like to start my talks with some basic questions. And the basic question today is, what are the roles of the build system in your organization? We are all a group of developers. Think about it. What does the build system do in your organization? Now, if it was live face-to-face, I would ask the audience, but here I just ask you to kindly write the answers down to yourself. Now, to me, the build system has three major roles. One is to provide feedback for any change that is done to the code base. The second is to create the deployables and put them into the right places. And the third is to keep the code stable, because we all like to check out to think that the code is okay when we check out when we check it out and start to mess around with it. To those requirements, we add another requirement, which is to work fast, because the build system is not the business of your company, unless it is, but usually it's not the business of your company. It's the necessary evil thing that you have to do. So it's better that this process would work just like that. And the second is continuous integration, which talks about how fast we integrate between the different modules in the company. So let's say that we have this build chain, and there is a change in the domain module. So how fast will we give feedback about the impact of this change to downstream modules, and how fast will we build all the downstream modules? And I claim that all of those requirements together creates quite a challenge, because how does our system provide feedback about the change before it is merged? Do we give feedback about the downstream builds? Do we give just feedback about the current module? How long does it take for a change to propagate to all of the dependencies? Our system must have some kind of triggering chain, right? The change here should trigger a change here, should trigger a build here. And while this triggering chain is happening, do we allow new builds to happen in this module? Do we block everything? If something is broken here, do we allow builds here? Do we keep our build correct, or do we allow things to work faster, but somewhat incorrect? And this might seem a little difficult with this small build chain, but when your organization is big enough, this is how the execution tree looks like, right? It's something a lot more complicated, a lot more, harder to manage. And this is where we were 3 years ago. The build system for the backend code, we had about 150 backend developers, about 5 million lines of code. Our build tool was Maven, and the build system just couldn't handle it. The master stability or the main branch stability was often broken. In order to get feedback about my change, I had to wait sometimes an hour. In order to get my deployable ready, sometimes I had to wait hours and even a day. And we developers, we don't like to wait. Developers were super frustrated from the build system. Those are real examples from our support Slack channel. Developers were waiting and waiting and waiting for their builds to happen. The build system was one of the biggest bottlenecks in releasing a new change to production. And this is not where we want to be. Build system is supposed to help push changes to production and not to be a bottleneck in it. And so we knew that we had to look for a solution, a build system that would offer a short build times, that the builds would stay correct, and more importantly, a build system that would work with the size of Wix that was very big back then, but also even bigger now. So a build system that can work with any size. And the reason that we're here today is because we think that we've succeeded quite well. We moved from Maven-based build system. Sorry for the barking. We moved from a Maven build system that just didn't work well to a build system that works pretty fast and is pretty stable, even now when we're even more than twice than the size we were in 2017. So you might be wondering, so what was changed? What did we change in our build system? So first, we changed the build tool. We moved from Maven, that we all know as the build tool that builds Java and other JVM programming languages, into Bazel. Bazel is a modern build tool that was open sourced by Google at 2015. It has been used inside Google for even longer than that, building over 2 billion lines of code. So we knew that this build tool can scale well. Since then, it has been adopted by a lot of big companies, Salesforce, Uber, Lyft, and many, many, many more, Airbnb. It's language agnostic, in its native form, it can build Java and C, but you can easily extend it into other languages, and Wix actually maintains the extension of Bazel for Scala, which is our main programming languages for the backend. And it comes with a tagline, fast, correct, choose to. So we don't have to compromise speed to get the correct build, and we don't have to compromise correctness to get a fast build. And really liked it, and it's really what it's offering. So that was one thing that was changed, but not only that, we also changed some of the methodologies, whether it was because Bazel drove us into doing so, or we just knew that we want to change something to make the system more stable or faster. So, for instance, we moved into monorepo methodology. We moved to protecting our main branch. We moved to source dependency and much more. And today, I'm going to focus on those principles that made the build system stable and fast and something that can work at scale. I'm going to talk about 6 principles. Some of those principles were a hard requirement of Bazel, and some of them are stuff that we added in. And even more important, I'm going to talk about in a Hinge site the prices that we had to pay in order to apply those principles in our dev organization and are still paying. So since not all of you are using Bazel, and maybe Bazel is a new concept for some of you, I want you to think with each principle on whether your code base, your build tool, your developers can actually apply those principles. And if so, maybe you can change something and optimize your build system. So let's just start. We'll start with the first very basic principles of keeping your build reproducible. If you look at the smallest unit of build action, you'll see some input and action that you do on this input and output. For instance, you can take, for examples, you can take compilation of Java. Okay, so the input are Java files, your compiler. The build execution is running the compiler on the Java files and giving it also all of the dependencies, and the output are the class files. So this is just one build action. Now, this action will be reproducible if I run this the same action 1,000 times in different times of the year, and I'll get to the same output. The output must be a direct result of the input. How do we do that? We have to make sure that the input is very well defined. So all those snapshot dependency, latest dependency, floating dependencies are something that makes the build non-reproducible, because every time you run the build, it will take a different input. You have to have minimum assumption on the running environment. So you have to put into your input the tools that you want to use, the JDK, the version of Python, no matter what is your build system, but no matter what is your build tool, but you have to put inside the tools that need to apply into the inputs. And to be extra safe, what Bazel does is that it puts the execution itself inside a sandbox. Sandbox that gives you a hermetic file system and hermetic network. So you can't really go to the internet. The internet is not something that is reproducible. A resource on the internet can appear today and tomorrow can return something else. So it actually closes the execution inside the network sandbox, and it closes the execution inside file system sandbox. So the temp directory that one action sees is a different temp directory from another action. So that actually promises that the output is a direct result of the input. Now, moving to this thing, and this is in every principle, I will have a chapter about prices. Moving into a reproducible hermetic action had its prices. We had at Wix some test that ran the Docker client and tried to pull images from the Docker Hub. And this is going to the internet. And now when we run things in a hermetic way, we have to pre-provide the test with some images that were pre-downloaded and just load those images as part of the test. So we had to rewrite some of the test. Also, and this wasn't a change because this is how we work at Wix. When we run end-to-end test or integration test, we also need to work against some collaborators. It can be a database or another server that you need access into. So our test actually starts their own database, starts their own fake servers. And this can create some resource overhead, some more time to start up your test environment or to tear down your test environment. So there is some overhead. Also, if your code base was used to also always get the latest version of some third party, and you didn't want to define, oh, now the latest version is 3, so take the version 3. Oh, now latest version is 4, take version 4. If you move into well-defined inputs, you have to have someone that will go every week and check what is the latest version, or some kind of automation that will automatically update this within the source code. So first principle, we're done, reproducible. We're moving into the second principle, maximizing your parallelism. Now, this can sound quite simple, right? If you have an execution tree with dependencies between the different tasks, doing everything in parallel would be much faster than doing just every task sequentially. But surprisingly, not every build tool supports this action. Maven, for instance, it has a way to run stuff in parallel, but it's not in the way that it's supposed to. It runs some actions on every module in parallel, but every module on its own would run sequentially. And when you talk about running things in parallel, you have 2 levels of how to do that. The first is to run things in parallel just locally using multiple processor or multiple threads. And then you're bound by the number of CPU and RAM. That your max parallelism is bounded by the CPUs or the amount of RAM you have on the machine. Or some build tools like Bazel and Gradle, I think, support remote workers, which is a service that will get from the build tool all the inputs that needs to be done and description of what needs to be done. It will do everything remotely. You delegate the work into a remote worker, and it will return you the output, the result of it. And then the build tool becomes just a scheduler of remote executions. And then you can do hundreds of things, thousands of things in parallel if your execution tree allows that. And if your remote worker service supports that, then you can do a lot more in parallel. So prices here is for at Wix, the developers were used to just run the build. The build would take a lot of time, so they went to do other stuff on their computer. Now the build would actually utilize all of the CPUs, all of the RAM, and on some machines, on some builds, the computer would just halt. So they had to limit Bazel and tell them, oh, you think you have 8 CPUs, now work with 6 CPUs. And for remote builds, this just adds another cost for the build system, because now you need to have a team that will operate and maintain this remote worker, or you need to pay for an external service provider. This remote worker must be something that will have a very low latency with the build machine. And we have to make sure that it's performant enough, that everything works well, that everything works well there. Continuing on to the third principle, smart incremental build, not just incremental build, smart incremental build. So let's say that this is the execution tree and everything was already done, and now something has changed just at the tip of the execution tree. So it can be faster, it might be much faster to just do those 2 actions and take the cached result of all the other actions, because we don't need to redo them. The inputs for those actions did not change. But for that, you have to have a reliable cache. And I'll explain what is a reliable cache. Let's start with what is not reliable cache. Let's talk about the Maven classic cache, the .m2 or the Nexus Artifactory protocol. So it all relates to the cache key. In Maven, the cache key can be just the Maven identifier, the group ID, artifact ID, version. I hope that you know that. And with this identifier, the developer can go to the cache and get some cached results. So in here, for example, I have a developer that works on the bar module, and she consumes the foo module. So when she just checked out the code, she built the whole project, and everything was saved into the cache. And from that moment on, she started working only on her bar project and took the foo output from the cache. But what happens when she will pull the code from master, and now the source files, the inputs that create foo module were changed? She will continue working with the stale version of foo from the cache because she doesn't know that something was changed, and then she will get to an incorrect build. And now you have the trade-off of whether or just working with an incorrect build but faster, or recompile, rebuild the whole project, and then everything is much slower, but then it's correct build. With Bazel, the caching system works differently. With Bazel, the cache key is actually a hash of the input. So when she will go to the cache, she will go with the hash of the input of foo, and the cache would return, no, I don't have it, a cache miss. I have only red, 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 and what you need is red, red, yellow, yellow. And this would tell Bazel, hey, you have to build this input and update this in the cache. And now the developer here is happy because she knows that she can trust the cache. So if there is a cache hit, she knows that it's actually the latest thing that corresponds to the input. So if you can rely on the cache, you can save tons of time. And in here, you can have just local cache that behaves that way. And you can also have remote cache that behaves that way. Local cache would help you to have incremental builds after your first run. And remote cache can actually help you share the cache result between all of your build machines, all of your developers. And then you can save tons of time, because even on your ephemeral machines, even on a vanilla machine that just checked out the code for the first time, you can enjoy the cache result. I can tell you that at Wix, there was about 95% save on average for some repositories by using the cache in a proper way. So prices for cache, you have to have this principle, the first principle that I talked about. Everything must be well defined, and you have to know that the output that you're consuming from the cache are direct result of the input, because the cache key are the inputs. And if something externally affecting the outputs, in those cases, then you can really rely on the cache. Not all build system work that way. I don't know. I know that Maven that doesn't work that way. I don't know if Gradle offered new features around that. But Bazel for sure works in a reliable cache with a reliable cache, and this is what makes the build system so fast. Let's move on to the fourth principle, fine-grained build unit. Now, let's look at this build tree, okay? We have five modules. The first module here is pretty big, the blue module, and two modules depend on it, one small and one big, and another module depends on this, a smaller module, and another medium module that depend on this. What if we could just break all of those modules into much smaller build units and cleverly define the dependency between those small units? Now we can do a lot more things in parallel, and now each unit is much shorter to do. So in here, if we had to compile 600 source files, so here we just compile 12 source files. And also, if you have this reliable cache feature, then every change would just cause a lot less cache invalidation. So every change would so building everything would take much less time because there's less cache invalidation. Now, I want to talk about the prices here because this is something very important that we have experienced at Wix. If you have this situation, it's very easy for a developer that works here in this module to work without worrying about too much about dependencies, because he works in this area and he depends on this area. Everything is in one module. But now when his project is now spread across a lot of dependencies, he has to work a lot harder in order to get the dependencies. Because when he needs something from here, he has to add some dependency. When he needs something from here, he needs to add another dependency. So they need to work a lot harder in order to describe the dependencies. And the mitigation for that is for the DevX team, the CI team, the build team, to provide some automatic tools to manage the dependencies, to know when to add and when to add the dependencies and which dependencies to add. Another thing is that it's not very easy for you to know how exactly to break this code into smaller units and how to define the dependencies between them. You have to have some smart analysis tool in order to get from here to here. Good. So we'll move to the fifth principle, which is a mono build on CI. Let's say that this is your build project. Okay, this is the whole project. This is the company. Okay, the whole all the modules in the company and the dependencies between them. How do you build everything? Okay, how do you build everything with the build server that you have? And now again, write the answers down to yourself. Two ways we can think of. One is to define a job. Let's say it's a Jenkins job for each module, and define dependencies between those jobs, triggering rules between those jobs. So the build server would be in charge of how to orchestrate everything and to do things in parallel. Everything, all the triggering must reflect the dependency between those modules. You have to constantly update the build server configurations, and this would work. With this is where we were 3 years ago. We had Teamcity, but the issue with that is first, this behavior cannot be replicated locally. So 3 years ago, we had situations where building the whole project was only possible in the build server. Locally, a developer will have to wait an hour, 2 hours in order to get the same behavior because it doesn't have this level of parallelism. The second issue is what happens if I want to go into the feature branch and I want to check on this feature branch, what is the impact of this module on all the company, on all the organization. So now I need to replicate all of those build jobs, and now I need to create some kind of cache that is shared between those jobs just for the cache. I've been in companies that try to do stuff like that, and we try to do stuff like that at Wix. It's possible, but it makes things much, much, much more complicated. And we want to be in a company where we support endless amount of branches and give a feedback, give full feedback for every branch. So another thing, if you have a build tool like Bazel that can orchestrate remote worker that has its own cache mechanism, so all you need is just one build job that will do everything. Okay, we'll just run the build tool, and the build tool will be in charge of delegating the work to remote workers, being in charge to calculate the execution tree. And now it's much easier for a developer to do the same things locally. And it's much easier for me as a CI engineer to provide a full build also on branches. And now I can give a full feedback also on branches. Yeah. So the thing about doing that, and this is something that actually Bazel drives us into doing, is that it requires a monorepo. It requires us to consolidate all of those project-based repo into one big repo and have all the code in one place. It's something that is done in a lot of big companies. It's done in Google, it's done in Facebook, Twitter. They just put all the code in one place. But I know that in smaller companies, in small, medium companies, they used to have a repo per project, and on each repo, they have their own automation tools, their own GitHub actions, and developers usually don't like to share repository with other teams inside the organization. So you have to sit down with them, understand their needs, and see how you can mitigate that in order to get them to agree to live in the same repo as other developers. Another thing is that you want to have a smart incremental build. You don't want to actually build everything on each build. You want to build just the things that has changed. And the last things, I would just touch on it a little. Git has its own limitation with the amount of code you can throw at it. When we tried to put all of Wix code into one Git repository, it took us, listen, 15 minutes to run Git status. Minutes, not seconds, I'm not wrong. It took us 15 minutes to run Git status. So at Wix, we actually work with several repos. We consolidated most of the code, thousands of repos, into 50 repos. And that created quite a challenge for us to work in a virtual monorepo. That there is another talk about that. But if you can put all of the code into one single repo, that will be preferable. So we're at the last principle, which is to do checks before you merge the code into the main branch. So what happens when you depend on broken code? Your code base just cannot build, right? You're blocked. And why does it happen? Why does it happen in some organizations? So also at Wix, 3 years ago, we were used to let developers just push the code into master. And the build tool would run the build and provide a feedback that the build was broken, and then the developer would have to fix it. But that was a little too late, because after the broken code was pushed into now it's called main branch, right? Not master branch. Now after the code was pushed into the main branch, the other developers were just blocked because they are consuming a code that is broken. And this is something that happens a lot. And this was the #1 reason for master branch instability. Another way is to have an automatic check for the build on the PR. Okay, you have to force the developers to work on PRs, on branches, and not on master. The only way to merge things into master is after you get a green light from the build server on the branch. You can have this thing manual, so the developers would open a PR on GitHub. The build server would provide the check, and then the developer can see that the check that he got the green light, and then the developer can merge the code. And you can also have automations around it. You can say the developer can push the code into branch with the intent to merge, and something automatic would run the test. And when the test is when the build is finished, it will automatically merge it into the main branch. In this situation, the main branch would be 99 or maybe 95% stable. There are some cases that we can talk about where main branch can be broken, but in most cases, the main branch is green, and all the developers can trust that when they check out the code, they can just start messing around with it because it's green. Because its baseline is green. Prices around that is that this creates just another hop before production. Okay, so if the push was green, then it will probably be faster for the developer to just push to the main branch. So now we assume that the push might be red, and now there's another hop. There's one build for the change in PR, and another build for the change in the main branch. But if you have a very fast build or very good cache that is shared between everything, then this is a non-issue. And with that, I think we're done with the principles that I wanted to talk about. And from here, I want to talk about how did we do that at Wix? How did we change the build system? And there's a whole talk just about that that I gave in the last year BazelCon, but I'll give you just the gist. The first step is to understand that you have a problem, or you're gonna have a problem very, very soon. You have to get enough engineers and managers on board. It can be something, it cannot be something that will be done just by your CI team, just by your build team. It has to be something that is done with the engineering team, with a joint effort. At Wix, we created a research team that would go and check what is the best build tool that can work for us. We found Bazel. We found that Bazel is a good build tool, but there is some things that needs to be done around the Scala extension for Bazel. So we went into maintaining the extension to Scala. We found out there are other issues around Bazel, and we tried to mitigate them before we moved into Bazel. We built an automatic tool to migrate from Maven into Bazel. We actually open sourced this tool under the name Exodus. You can go and look it up. And we did it. We moved gradually from the old build system into the new build system. And now the builds are much faster. But an important thing to remember is that we always try to improve. We always try to see whether there's stuff that can be done in order for the build system to work better. To finish this talk with some numbers, because I know that you're interested, we moved from 2017 to today, where the master is mostly stable, like I said, 95% of the time, to get feedback about the code. And now the code is even twice as big as before, so 10 million lines of code. You have to wait between 4 to 15 minutes, which is amazing. And to get your release ready, you have to wait between 10 to 15 minutes. And we're very proud of this thing. Like I said, this thing didn't come for free. We had to pay a lot of prices. Most of the tools or a lot of the local dev took a big hit around that, because a lot of the local tools are built around Maven or around Graindale, and Bazel is a quite new build tool, and we had to make sure that the tooling around it are good enough for our developers. but overall, we're very happy with the result. Um, so thank you very much. I hope you found this talk interesting.